Hi friends, look at the question now. Figure shows two concentric spherical conducting shells which are given charges Q1 and Q2 respectively. They are asked to find out the electrostatic potential of each shell. I repeat the question. Figure shows two concentric spherical conducting shells. This is shell 1, this is shell 2, which are given charges Q1 and Q2 respectively. You can see in the figure Q1 and Q2 respectively. Find the electrostatic potential of each shell. Okay. This is a question to be answered. Before I move to the details of this question, I request all of you to try for a minute by pausing the video. Hope you have tried the problem. Before I start to discussing this problem, let us recollect two aspects. Well, the first one is something that we discussed earlier. The second one is what we discussed yesterday. Those who haven't seen the video, I request you to see the previous video. Okay. And the question I want to ask you is, consider a spherical shell of radius r carrying a charge q. What is the potential at A? What is the potential at B at a distance small r? And the potential at C at a distance x? These are the three questions for which you have to find the answer. Already it is there in your notebook. Hope you got the answer. What is potential at A? Hope you can see this. This is equal to KQ divided by R. What is potential at B? It is KQ by small r. What is potential at C? No more I'm writing, I will say VC is equal to VA is equal to KQ by R. Right? Now this is first concept. The second concept which I am going to ask you is, what is the charge appearing here? It is 0. What is the charge appearing here? Minus Q1. What is the charge appearing on total here? It is Q1 plus Q2. Now let us write the potential of sphere A. One important point you have to consider here, that this is okay. I will call this as sphere 1 and this is sphere 2. So I am finding what is VA here stands for potential at the surface of the first sphere, or I will use V1 because we have used symbols 1 and 2. So V1 is the potential at the surface of sphere 1. V1 is the potential at the surface of sphere 1. Tell me, which all charges constitute potential at the surface of sphere 1? Which all constitute the potential at the sphere 1? Obviously, the charge Q1 will constitute the potential at the surface of sphere 1, which is KQ1 by R1. No doubt at all, because charge Q1 is on the surface of sphere 1. Now, look, this is the inner surface of sphere 2 has got a charge minus Q1, and the surface of sphere 1 is inside the second sphere. Surface of sphere 1, this is an important point to be noted. The surface of sphere 1 is inside sphere 2. Surface of sphere 1 is inside sphere 2. Now, what you know about the potential at any point inside a charge conducting sphere? You know it is equal to the potential at the surface. Right? Potential at the surface. Now, I am considering the potential due to minus Q. Considering the potential due to minus Q1, which is on the inner surface of second sphere. On the inner surface of second sphere. And the surface of sphere 1 is inside the sphere, which means the second point I can write is K into minus Q1 divided by the potential due to this minus Q1, and this sphere is inside the second sphere. It is little difficult to understand, so please look into that idea in detail. This is inside the sphere. At any point inside a charged sphere, the potential is same as that on the surface. So I will say this is R2, because this radius is R2. The thickness of the sphere is negligible. Okay, then what about? So this is a contribution from Q1. I got KQ1 by R1. This is a contribution from minus Q1, that is K into minus Q1 by R2. Then the next one is the total charge appearing on the surface of the second sphere is, outer surface of the second sphere is Q1 plus Q2. Again, this point is inside the sphere. Inside. What is the potential inside a charged sphere? What's the potential inside a charged sphere? It is same as the potential on the surface. So I would say it is K into Q1 plus Q2 divided by R2. All total, what will this appear to be equal to? Okay, minus KQ1. Okay, this will give you KQ1 divided by R1 plus, there is minus KQ1 by R2, there is plus KQ1 by R2, so these two will cancel. This is KQ2 divided by R2. That is total potential V1 is equal to KQ1 by R1 plus KQ2 by R2. This is the potential at the surface of sphere 1. This is an important point to be understood. Let us take now the potential at the surface of the second sphere. Let me take it as V2. Yes. Here we have to consider the contribution due to Q1, contribution due to minus Q1, and contributions from Q1 at the surface of this one, contribution of minus Q1 at the surface of this one, contribution of Q1 plus Q2 at the surface of this one. Okay, ready? Take it. Now the surface of the second sphere, where is that located? It's at a distance R2 from the first sphere. It's a point outside, I would say. When I discuss this problem, I used to say inner sphere is inside the outer sphere and outer sphere is outside the inner sphere, right? Inner sphere is inside the outer sphere. That is where I use this concept. And outer sphere is outside the inner sphere. So contribution from Q1 at this point, at a point here, this distance is R2, this distance is R2, this distance is R2, this distance is R2. Everywhere it is at a distance R2 from the center of this sphere 1. Yes. So for an outside point, that is VB, it is KQ by that distance. So what is contribution from first sphere? V2 is equal contribution due to Q2. It's at a distance R2 from the center of the first sphere and it is outside the first sphere, right? So it is KQ1 divided by R2. Now what is the contribution from minus Q1? It's very simple. Plus K into minus Q1 divided by R2. Plus, what is the contribution from this one? It's on the surface. Minus Q1 and this are on the surface. What's the contribution from this one at the surface of this one? It's very simple because this charge is located on the surface of this one. So this will give you K into Q1 plus Q2 divided by R2, and finally we are at the answer, which is K into Q1 plus Q2 divided by R2, because these two terms cancel. And that concludes our problem. You can ask your doubts about it through WhatsApp or in the comment box. Thank you.